So our next section is over derivatives of exponential and logarithmic functions. And we're primarily going to focus on our natural logs and our natural base exponents. But we'll also touch on other exponent bases as well as logarithms. So the first one, and we're going to talk about the derivative of our natural base exponent. So that is when f of x equals e to the x. Okay, this derivative is, and it's so difficult, the derivative of e to the x is e to the x. All right, and here's why. Any natural exponential functions, it's the variation of the chain rule. Actually, no, it is the chain rule. If you have e to the f of x, then derivative of the outside, keep the inside, times derivative of the inside. Now, the derivative of e to the x shows up a lot. You have to know that derivative of e to the x is e to the x. Okay, but it does come from chain rule. All right, I want the derivative of e to the sine x. Okay, so f prime be derivative of the outside, keep the inside, times the derivative of the inside. About the only thing you would do is rearrange it. But that's it. Okay, derivative of the outside, so that's your e. Keep the inside, times derivative of the inside. So rearrange it so it looks a little bit better. But there you go. All right, when you have a coefficient, that doesn't change anything either. It kind of attaches with it. So derivative of the outside times the derivative of the inside. Oh, we've got product rule here. Keep the first times the derivative of the second. That's your natural base. So e to the 3x times 3 plus keep the second times the derivative of the first. Let's see. All right, let's see if I simplify this. Like terms. So multiple choice. That's what it would look like. Moving on, another one with the product rule. Times the derivative of the second plus keep the second times the derivative of the first. That's about as far as you can go on that one. All right, this one's kind of designed to mess with you a little bit. So the first thing I would do is rewrite with the rational exponent. Well, if you remember your exponent rules, when you have a power raised to another power, you multiply. So this is really 1/2 times 2x minus 6, which is really just x minus 3. Now I can take its derivative. Derivative of the outside, keep the inside, times the derivative of the inside. Moving on, we've got quotient rule. So low, d high, so e to the 5x times 5, minus high, d low, all over low, low. Okay, so what have I got? I can do 15x squared, e to the 5x, 6x, e to the 5x, over 9x to the 4th. And I am going to factor a 3x e to the 5x left. So that's 5x minus 2. So 9, or 3 goes into 9 3 times. Our derivative, e to the 5x minus 2, all over 3x cubed. All right, moving on to our differentiation rule for natural logs. For natural logs, f of x equals the ln of x. I'm going to start with that derivative because that's one you just have to know. The derivative of ln of x is 1 over x. Similar to your natural base exponential or natural base log, it kind of works like the chain rule. So d dx of the ln of f of x equals f prime of x over f of x. All right, so just in case you're kind of struggling with what the f of x is, the f of x is your argument. So it is whatever is inside your parentheses for your natural base log. All right, so f of x represents your argument. All right, so we follow this derivative of the argument, so 2 over the argument. Okay, I'm not even going to stop the video. Derivative of the argument over the argument. Derivative of the argument over the argument. That one you do is tangent. Okay. Rewrite so that your argument using your logarithm rules, exponents become coefficients. So that coefficient doesn't really affect anything, so we're just going to keep it. So then derivative of the argument over the argument. 2 cancels 2. There's our derivative. All right, I'm going to suggest that you write down these calculator instructions to help. So for each function, find the value of f prime of x at the indicated value using the graphing calculator. Determine the functions increasing, decreasing, and so on. All right, so my first function is 3e to the x times sine x. Okay, so you're going to go to your graphing calculator. Okay, this is an emulator, so it's not exactly the same, but it's pretty close. You're going to go to your y equals. You're going to type in your function, 3. Now the E button is right above the STO button. It's third one up from the left. Times sine x. Now double check your mode. Make sure that you're in radians. All right, so you can go back to the main screen. Second mode. And then you're gonna hit math. And then choice number 8. Now on the 84, you do have to type in the x. You see where it says d over dx? You have to put in the x. Then you're gonna hit alpha, trace, y1 should be highlighted, enter. And then scroll over where it says x equals, and we want to put in -2. Enter. All right, we only need 3 decimal places for AP Calc. So f prime of -2 is -0.538. All right, then it asks, is f of x increasing, decreasing, and so on. So because f prime of -2 is negative, we know f of x is decreasing. So f of x is decreasing at x equals -2 because f prime of -2 is less than 0. Okay, now it's the same function. And so the great thing about that is I don't have to rewrite it, but I do need to go math, 8, alpha, trace, y1. And this time our x value is 1. So 11.268. So f prime of 1 is 11.268. That's positive. So f of x is increasing at x equals 1 because f prime of 1 is positive. Okay, new function. So go to your y equals, clear, your fraction bar, and I need the ln of cosine x over x squared. Again, make sure your mode is in radians, so we're good. Go back to your main screen. Math, 8, alpha, trace, y1, x equals pi over 3. So -0.372. So that's negative. F of x is decreasing at x equals pi over 3 because f prime of pi over 3 is negative. All right, now a is pi. Math, h, alpha, trace, y1, x equals pi. Enter a complex instead of a number. That means we were taking this I can explain this right. You're getting a 0 in the denominator. It's undefined. All right, if I do that on my actual 84, let me see what I get. Let's see. Alpha trace y1. All right. So you end up with non-real answers. And so that means that your answer was imaginary. So it means it was undefined. So f prime of pi is undefined. Well, if f prime of pi is undefined, that means it was a vertical tangent. F of x has a vertical tangent at x equals pi because f prime of pi is undefined. Okay, vertical lines have undefined slopes. Okay, new function. Go to your y equals, clear. Let's see, second e tangent 0.34x. Double checking, all right. Math 8. Nope, clear that. Math 8. Alpha trace y1. There we go. What was it? 0. All right, there's 3.0 or 0.340. That's positive, so f of x must be increasing. Because f prime of 0 is positive. Last one on this page, and this is, before we go straight to the calculator on this one, to rewrite this, what's being squared is sine. The sine of the ln of x, double parentheses there, square. So this is how you would enter it in the calculator. All right, so 5 parentheses sine ln of x. There's going to be 3 parentheses there, 1 for the ln, 1 for the argument, and 1 for the sine, and all that is squared. Math 8. Okay, sorry about that. We had an add, so I stopped it. So math 8, alpha trace y1. I forgot what it was. 1. All right, guys, so if you see that with a -5, with a little e to the -6 or whatever, that means 0. I wonder if I get the same thing on this, my actual calculator. Math 8, ddx, alpha trace by 1. Yeah, I get the same thing on mine. You get the weird e thing. So when you get the weird e thing, that means 0. Okay, so f prime of 1 equals 0. Since the derivative at 1 equals 0, then f of x must have a horizontal tangent. Because f prime of 1 equals 0. All right, now this page I want you to pay such close attention to, okay? Because it's not simply finding the derivative at specific values, it's interpreting the meaning of the derivative at that value. All right, so what we've simply been doing is we're talking about when the derivative is positive, the graph is increasing, the f of x is increasing, the derivative is negative, f of x is decreasing, but that means something in terms of a context. If it's decreasing or increasing, that is a rate of change. All right, so when we're speaking about quantities like it says right here, they're doing so at a rate. All right, so the derivative represents the rate at which a function is changing, which means it's incredibly important to read what those variables mean. So in example 7, number of people entering a concert. Number of people entering a concert, that's major. Can be modeled by the function f of t equals 560 e to the sine t, where t represents the number of hours after the gates are open. All right, so I know that the function is modeling the number of people entering a concert and that t represents hours after the gate is open. Okay, now find the values of f of 1 and f of 1/2 and f prime of 1/2. Using correct units, explain what the value represents in the context of this problem. Now, if I can remember how to find a value, we'll be doing good. Let me check. Nope, not there. I'm going to figure it out real quick. Stand by. All right, sorry about that. I had to remember exactly which way to do it because there's an easier way than the way I used to do it. So I got it. All right, first thing I want to do is put this in my y1. So I'm already in y1, 560 e to the sine t. So I don't have a t, I can use the x though. All right, so go back to the main screen. And this is the awesome part. This was the easier way. You're going to hit alpha, trace, y1. We're finding the value at 1/2. So y1 of, put your parentheses, 1/2. Enter. So 904.481, so 0.482 if we round it correctly. So f of 1/2 is 904.482. And it means, since that's half, and t represents hours, so this is half an hour, after the gate opens, approximately 904 people are entering the concert. All right, that's the value. Now we need to find the derivative at that value. Okay, so math 8, alpha trace y1, 1/2. So 793.757. That's a rate. So this means that 30 minutes after the gate opens. The number of people entering the concert, be specific. Is increasing at a rate of 793.757 people per hour, T for time. Okay, same function. So the number of people entering a concert, multiplied by the function, where T represents number of hours after the gates are open. So part B says how many people have entered the concert 2 hours after the gates are opened. All right, it mentions nothing about a rate here. This must mean we just want to find basic value f of 2. Because it doesn't mention the rate on that first question. It just wants number of people in the concert 2 hours after the gate open. So we're going to do alpha trace y1 parentheses 2 1390.244 specific here, word problem. People are entering the concert 2 hours after the gate has opened. Now it wants, the next question says, is the number of people entering increasing or decreasing? These phrases here, increasing and decreasing, means we're looking at the rate of change. So that means I need f prime of 2. So math 8, alpha trace y1. Okay, negative 578.545. The number of people entering the concert. I don't know where this concert is. That's a lot of people. Two hours after the gate is opened. Now, it wants to know if it's increasing or decreasing. That rate is negative, negative 578. So is decreasing. Because f prime of 2, what am I trying to write here, is negative. All right, we've got a new function here. After being poured into a cup, coffee cools so that its temperature, capital T of lowercase t, is represented by our function, where t is measured in minutes, so time in minutes, and capital T of t is measured in degrees Fahrenheit. So what is the temperature of the coffee 5 minutes after it's been poured into the cup? No rates of change here. This simply wants capital T of 5. Okay, so we go to a calculator. All right, so it was 70 plus 110 E negative x over 2. And I want t of 5. So alpha trace y1 parentheses 5. So 79.029. Okay, the temperature of the coffee. Five minutes after it's been poured. Is 79.029 degrees Fahrenheit. All right, so is temperature decreasing faster 1 minute after it's poured or 3 minutes after it's poured? Give a reason for your answer. So we're talking about this decreasing piece, which means we're looking for the derivative at 1 and at 3. So we need t prime of 1. And we need t prime of 3. All right, so math 8, alpha trace my 1, and x equals 1. Negative 33.359. Okay, now we need to be specific here. This is degrees Fahrenheit per minute. Math 8, ddx, alpha trace y1. This is x equals 3. Negative 12.272. Degrees Fahrenheit per minute. Okay, so the faster rate, right, we're talking about negative numbers. So the faster rate is the steeper negative. All right, and for that you want to look at like absolute value here. So if I take the absolute value of this negative 33.359, that's just 33.359. And this one would be 12.272. All right, so 33 is much steeper, because think of it as 33 over 1 and versus 12 over 1. So imagine going up 33 units and over 1 versus up 12 and over 1. Okay, this is much, much steeper. So that rate is much, much faster. So the temperature is decreasing faster at t equals 1 minute because, now we did this with absolute values here. So t prime of 1, absolute value of t prime of 1 is greater than absolute value of t prime of 3. All right, now I started with the derivative of e to the x and the derivative of ln of x because those are going to be more prominent in AP Calc than the other exponential and the other logarithms. But it is still important to know what those derivatives are. So I'm going to start with the derivative of a to the x. So I actually want you to consider this as the derivative of a to the f of x. Okay, so the derivative of a to the f of x is a to the f of x times the ln of a times f prime of x. Okay, so if we consider that with e to the x, okay, e to the x is still an exponential function, so I can use this. So first thing it says is a to the f of x. So e to the x times, then it is the ln of e times the derivative of the exponent. So what? Well, the ln of e is also 1. So this is e to the x times 1 times 1. So the derivative of e to the x is e to the x. Now the derivative of the logarithm. Okay. Again, we're going to consider it so that it is not log base a of x, but log base a of f of x. Okay. It is f prime of x, so the derivative of the argument over f of x times the ln of a. Okay, so again, let's consider with the ln of x. Okay, f prime of x, so that's the argument. That's 1 over f of x times the ln of the base. Well, a natural log is log base e. So what is the ln of e? Well, ln of e is 1. So this is 1 over x. Remember, the f of x is the argument. So the argument there is the x. All right, let's look at example 1. You can see that the argument is just x. Okay, so if it's just x, the derivative of the argument is 1. I'm going to do it like this. Y prime, derivative of the argument, so 1 over f of x, so x, times the ln of a, that's the base, 2. That's literally it. But then you get something a little bit more complicated. Y prime, remember f of x is the argument. Okay, so f prime of x, that's going to be 20x squared over f of x times the ln of a, that's the base. Simplify. 5 goes into 20 4 times. Equals 4 over x squared ln of 6. Okay, now I'm not asking you to get real psycho with these, okay? But you do need to recognize some properties when you see them. All right, so when you're multiplying the arguments, all right, using the logarithm rule, you're really adding. That's a terrible 9. So remember from logarithms, when we'd ask you to condense and you get something like this, you would take the arguments and multiply them together. Okay, now I'm asking you to expand, so addition. All right, so starting with our first one, 5 to the 9. So the derivative of the argument over the argument times the ln of 9. Now we're here. And this time the argument, much more extensive. That is my argument. So 3x squared minus 6x plus 9 over the argument times the ln of 9. Okay, the only thing that we can do here, because this is a psycho type of fraction, I'm not asking you to go any further than this, because no, is simplify that fraction. You do it by reducing. 5 goes into 45 9 times. That's 8. So y prime is 9 over s ln of 9 plus that monstrosity. I'm not going to read it. I'm just going to write it. Times the ln of 9. And like I said, I'm not going to ask you to simplify that any further than this. This is it. This is as far as we need to go. We've got some exponentials here. Remember, the f of x this time is the exponent. So if we go back up and look, a to the f of x, ln of a, that's the base, times the derivative of the exponent. So the derivative of 4 to the x, 4 to the x, times the ln of the base, times the derivative of the exponent. That's it. All right, this time your exponent's 10x. So y prime, I gotta look because this is the one I'm not super familiar with. A to the f of x, ln of a. So a to the f of x times the ln of a times the derivative of the exponent. I don't really know how I can write that, to be honest. 10 times 3 to the 10x times the ln of 3? I don't know. That doesn't look right. I guess it is. Okay, we'll go with it. All right, last one on the notes. Exponent. So y prime, a to the f of x times the ln of a times derivative of the exponent. I don't know that I would simplify that very much further than that, to be honest. Maybe put the 20x cubed at the front. Definitely want to put that. That's exponents, oops. And then ln of 2. I really don't think there's a way to write that. I don't like the way that looks, but it's done. All right, and that takes care of our exponentials and logarithms.